Good morning, everyone. So yes, I'm Caterina Constantinescu. I will be telling you a few things today about how to go about choosing your a web app for your project. Basically, what I'll cover today is I'll kick things off with a brief hello from both myself and Global Logic. I will mention a few things about what I aim for with this talk today. And after that, we're going to dive into some details of almost a pretext that we're going to use to display a variety of tools, such as Shiny in both R and Python, and then a variety of Python tools, after which we'll wrap up with some broad conclusions, and I'll leave you with a blog post that you might want to explore if you want to know more. Now, in terms of my initial hello, I work as principal consultant at Global Logic, which is headquartered in Silicon Valley. It's also a Hitachi Group company with offices and engineering centers around the world, which is what you can see on that map. Before I go any further, I thought it would be really worthwhile giving a shout out to Yulia and Caterina that were selected by Forbes because of their talent in leadership within IT. So following on from that, what do I hope to achieve today via this talk? Basically, I would intend for this to be a gentle introduction to a variety of web app tools other than Shiny as well. If you're anything like me, you might have found yourself in a sort of situation where in terms of that exploration to exploitation spectrum of things, just because of lack of time, you might find yourself really often just falling back on something you already know how to use instead of dedicating some time just to explore what else is out there. So that's what I wanted to force myself to do by signing up to give this talk, and this is basically what I've discovered so far. Also, this might help you collaborate with multi-language teams because you might get a better understanding of what other people, where they're coming from, and how to address basically their experience if they're coming from a different one of these frameworks. So what example are we actually going to use to illustrate all of these frameworks? It's something I picked from the energy sector. The important thing is it's just some data, it's just an example. You shouldn't worry too much about what the data actually means. If you do want to go further with this, I have included a couple of links there, and I will make the slides available on my blog, so you can go explore further if you want to. But long story short, let's say we have some data from the energy sector and we want to create some forecasts for a couple of years into the future. And what that data looks like is this. We basically have a couple of categoricals. The first one, let's say, has to do with whenever a building was built. It might be from pre-1919 all the way to much more recent builds. We also have something that tells us where it's located within the UK. And after that, in wide format, we continue with a bunch of metrics that for each year, I think all the way to 2008, if I'm not mistaken, quantify usage in terms of medians or means for both electricity and gas. So basically what I'm saying is we already have in a fairly small data set 5 dimensions to deal with, like the building age, as I mentioned, the region, the energy type, electricity or gas, the time as measured by the year, and also the metric type, median or mean. So at this point, the idea is how do we deal with all of this information? Well, one way would be to create smaller chunks for us to focus on any point in time, and do that by creating smaller windows via input menus, and only focus on those whenever we create a forecast 2 years in advance, and whatever that forecast looks like, output it as a visualization usually. There are some exceptions, as you'll see. So hopefully all of that makes sense, and we're basically going to see how to go about doing that in Shiny and R first. So what do we have here? This is an example of what you might create. Now, I guess be gentle because this is not necessarily the way you'd want to show a forecast. There are no confidence intervals in there, but let's say for argument's sake, you do end up with a visualization of some sort like this, where you also allow yourself to focus on just particular subsets of the data. So for example, in this case, we have electricity in the Northeast, and this is what the forecast may look like. Nothing probably too unusual if you're familiar with Shiny, which I'm suspecting almost everybody is, if not everybody. So how did we go about building what you've just seen? Well, two key libraries that are used there for kind of no other reason other than the fact that they conveniently, for my purposes, happen to have versions in both R and Python. Plotly and Profit for the modeling part, and in the slides that follow, I'll show you some code, and in some cases some pseudocode where I skip over bits that are not that important. But if you do want to go into detail and kind of adapt these for your purposes, I have also included a link to GitHub. So what we have in this initial example is we just basically start reading in some data. For simplicity's sake, we hard code some values there in terms of the regions and building periods, and we also extract some variable names depending on what metric energy type we're interested in looking at. After that, nothing terribly surprising here as well, I don't think. We basically set up our interface so that it has a sidebar including the two drop-downs as you've seen before. Probably my bad there. I should have actually made sure that was changed to something more meaningful in terms of the ID, but let's just roll with it. And then we also have a main panel containing the Plotly output. Now, what do we have in the server function? We first have a reactive function that makes sure we only start looking at and modeling the parts that we really care about at any given point in time. So that means we're only going to look at a particular energy type and a particular region, and then we do some reshaping and things like that. I'm going to start skipping over things quite quickly because I have a lot of content. I think I got carried away slightly. So what happens further is we have this render Plotly reactive layer that pretty much achieves two things in one. So basically we start doing the forecasting here as well for all the building ages within a combination of region and energy type. We put them all together. We also add them to the observed data. And then we basically start outputting things after prettifying some labels into this Plotly function. And that is the story of how we ended up with this. So hopefully that makes sense, because now we're going to see what might have changed once we switch to Shiny, but in Python this time. This is quite a recent addition. I'm not sure how many people might have had a chance to play with this yet. Can I get a show of hands, maybe? One person? Okay. Okay, no, this is really good for me because that means I'm going to show you things that might be useful. So what we have here, I guess on a conceptual level, is pretty much the same. So we still declare all our information up front. We still declare what's supposed to go in the UI. Obviously, the syntax is, of course, different because this is Python, but structurally, it's more or less the same sort of stuff, except what would normally have been a line chart here, I wasn't able to actually integrate as Plotly yet, which I thought was interesting. So instead, just to show something, I've switched to a tabular output of the data itself. Now, having looked at the documentation, I think basically for now what's supported is other types of figures, and I don't think there is currently a dedicated way to integrate Plotly just yet. So if that's very important for you for whatever reason, I don't think you can do it just yet, but probably soon. So what that means in terms of what else we can do here and what the differences are from what you've seen before is we have these so-called decorators. So our selected data function from before, that was a reactive function, you need to preface it with something like reactive.calc, so it counts as a reactive one in this scenario. But again, in terms of the logical operations that need to be included, it's very much the same sort of stuff you've seen before. Again, in terms of what actually has to also be pre-done before actually outputting anything, either a table or a plot, again, we kind of define a function, but again, we need some decorators to connect it to the appropriate place where it needs to be sent in the UI, and we're also making sure to declare that this is, via decorator, a render table reactive piece of content. But everything else pretty much stays the same in terms of we're still making our forecast. We're still putting together the forecast part with the observed data, and we're still making some various manipulations to actually put everything together. Because of the reasons I mentioned, what would have been Plotly code in Python won't work here, so instead we're going to fall back on the table just to be able to show something after we run everything in a terminal, quite simply like that, following that syntax. So what we see as the output just basically looks like this. We can update the view as per usual, and basically everything will follow from there. Okay, so that's kind of the shiny component of the talk. Now we're going to dive into, bravely apparently, into the Python side of the talk. And what I thought was incredibly interesting is that for Streamlit, for example, the philosophy is completely different to Shiny. Another show of hands, has anybody used Streamlit here before? No? Okay, good. This is great. So what happens here is, instead of this entire mindset of having to declare things as reactive functions or rendering tabular output or anything like that, all of that just goes completely out the window, and you don't have to worry about it because Streamlit handles all of that for you. So what you actually end up writing is just a normal Python script with very minor tweaks to make it into an interactive app. Also, it kind of takes on the job of figuring out what kind of output you're even trying to visualize or show, be it a table or a visualization. You can wrap all of those into st.write, and it'll figure out for you what type of thing it's supposed to show without you having to have multiple versions of this command. There are exceptions, but this will kind of get you quite far for quite a few types of content. And it'll do you one better. Like sometimes you don't even have to bother writing even this. It'll figure out that if you have an object on its own line of code, that it needs to wrap it in this behind the scenes so that it outputs things. You can also cache things, and what I also thought was an interesting feature of this is you can actually run this on your phone, and if you're doing something like ML, I guess, you can use pictures as direct input for other things that the app can do for you. So what does this app look like in Python? So we have something like a decorator here to just cache things if we really want to. And as I go through this example, you're going to start to see that the differences from, like I promised, the differences from a normal Python script are really quite minimal, in just the fact that here we add a title, we add those two inputs that you've seen before, but they're simply stored as what appears as normal objects, except it will know that these are updatable here. It'll just kind of figure it out behind the scenes without the user, the coder, having to worry about that at all. Again, the st.write here at work, if we really wanted to actually output this as an interactive table, that's all it would take in this particular case. And everything else is pretty much the same in terms of, let's just create our forecasts, output them, and also show a Plotly chart. In this case, there is a minor change to st.plotly chart as opposed to .write, but it's still very simple in terms of what you actually are required to do as a coder. The output is this, and again, depending on whatever you require for your modeling purposes, it'll just kind of update accordingly. The really interesting thing is it also allows you to tick that little box there so that basically whenever it detects a change in the source code, it'll rerun itself. You don't have to stop and restart the app. So very, very different sort of philosophy, as I was saying, compared to Shiny. However, Dash is another sort of alternative that actually is a bit more similar to Shiny, relative to Streamlit anyway. So what this looks like, conceptually, I guess, is it relies on three key elements. The first two actually go in the so-called Dash layout. So that includes core components and HTML components. So these are your drop-downs, your date pickers, widgets that were frowned upon earlier. As well as outputs like graphs and tables. We also have a third element, which is the callback, which is the thing that connects the two and creates the interactive functionality. So with that in mind, what the code actually looks like in this particular case is basically the same as before up to this point where we declare our constants, we read in our data and everything, but then we start to create this controls object, for example, which, as mentioned before, starts to contain these HTML core/HTML components, which in this case happen to be our dropdowns. Once we have defined this controls object, we go with it in this app layout, again as mentioned, and compared or combined with the extra 2 elements I've added here for reasons that you'll soon see, need to be plugged into the app callback as well. What's important here is that everything or the way it works is there are these positional arguments that you don't really have to care particularly what these are called as long as they actually follow the structure mentioned before. The reason I actually added 2 outputs here is to highlight the fact that in this case, unlike Shiny, you can actually return 2 things from the callback. So instead of creating one reactive function as an ancestor, I guess, for 2 particular output types, you can actually use whatever you create within the callback and just output it at the same time at the very end. What this looks like is exactly like what you've seen before, but again, the thinking or the process, how you get there, is a bit different. So Gradio, I don't have a whole lot of time left, so I'll try to kind of run through these quite quickly. Gradio is a really interesting machine learning targeted solution. So to the point where you can host your demo on Hugging Face. Everything else kind of on a conceptual level in terms of what you need is similar, like you need inputs, you need outputs, and you need a function to create the GUI. But in terms of what you actually are required to do, this part is always quite familiar across all the solutions. But then we have to create a make graph type function, and what we end up plugging it into is this Gradio interface. So make graph appears here as the function we need. On the fly, we declare the inputs in here, and we also mentioned that we have a plot output from this. Again, a conceptual difference from, say, Shiny is that you don't by default get the reactive behavior that you're used to unless you actually set live to true, which actually makes sense, I think, for a modeling specific or an ML specific app, because if you have a ton of parameters, you don't want it to start recomputing your model when you've just made one change. Rather, what you might do instead is actually make sure you have all your selections made and then you submit them in one go, so that you can actually get your output, which is quite interesting as well. There are a few extra options that you might have heard of. Anvil is actually quite similar to, I think, Shiny actually, but the business model is very different in that their platform actually takes on all of the development work and the deployment as opposed to you having something created locally and then deploying somewhere. Flask and Django, really famous but really low level. Really interesting combination of tools there. So Voila and Panel combined with Jupyter Notebooks would help you in scenarios where you already have your work stored in a notebook and it's only much later in the process of development that you realize that, hey, actually what this project would benefit from is making that notebook interactive. So that's where those come in. Now, to hopefully wrap up with some conclusions, I'm not gonna try to position myself as the web app police telling you what you can do, what you can't do. So at the end of the day, just use what you're comfortable with. But I do have some suggestions and proposed decision points. So the first one, and hopefully this won't be like a super controversial point, but depending on your project and the problem you're trying to solve, it might be an idea to just leverage the heritage, I guess, of the language and the ecosystem that you're working with. So for example, for statsy problems, and without getting massively into the weeds of what counts as ML, what counts as stats, be that as it may, for example, for mixed models or generalized additive mixed models, there is much more tradition in the R ecosystem and much more eyes over time that have looked at packages for that. So if that's something you need, maybe you want to carry on in Shiny and just kind of keep going with the R solution to the end. But maybe if you're already using Python packages for ML, then maybe something like Gradio, which is specifically designed for ML, or even something like Streamlit might be a better option. And if you're not using any of those and you just are going for analytics or BI problems where you would benefit from a lot of control visually in terms of what the layout of the dashboard looks like, then maybe something where you can much more closely define what your inputs look like, then maybe Shiny and Dash would actually be best. A second sort of classification by project maturity, if you're just aiming for a POC or a demo, then Streamlit and Gradio might actually be your best bets. But if you're doing something that is far more complex than that and maybe actually stretches way beyond data science anyway, then maybe you might go all the way to Django, which will generate everything down to 404 pages for you. It's at that level. Or if not, at the very least, Dash and Shiny might actually be best. Other classifications will exist, but for lack of time, I'm not going to talk about any of that, and it also probably depends massively. You should also avoid bike shedding and agonizing too much about the fine details about what to choose, what not to choose, especially since you're not necessarily going to be stuck with a particular framework until the bitter end. There are solutions that allow you, for example, to embed a Dash app you already have in a wider Django project with stuff like Django Plotly Dash as a library. So, having covered all that, if you want to know more, and without swamping you with a list of stuff that nobody ever reads, if you do want to go further, I think a good place to start is this one blog post that I've pulled out there, but obviously a lot more is available. And yeah, with that, if you have any questions, happy to answer them, and also feel free to find both me and my colleague Miguel in the rigs.